So moving on to the fifth question, it says integral of sine of ax plus b into cos of ax plus b times dx. Okay. So mark this problem as important. Okay. Mark this problem as important. I'm going to solve this problem using two methods. Observe. Okay. So whichever is simpler for you, you can take it, but I'm going to share both the ideas. Listen to it. So solution here is, so the method one. So whenever you have product of sine and cos, so repeating it, whenever you have product of sine and cos, where sine and cos both have the same angle. So in this case, it is ax plus b, ax plus b. So since they have the same angle, what you can do is multiply and divide it with them 2. Multiply and divide with 2. Reason, when you have sin x into cos x, you are able to observe it is the product of sine and cos, and you have x and x here, right? So when you multiply and divide it with 2, then you will have 2 sin x cos x, which can be written as sin 2x divided by 2. So having said that, we can multiply and divide it with 2. So you will get 2 sine of ax plus b into cos of ax plus b, the whole divided by 2, the integral of this times dx. So 2 sine into cos, it is going to be sine 2. So 1 by 2 into integral of sine 2 of ax plus b times dx. Right. Now this clearly gives an indication that we need to substitute ax plus b as t. Or else what we do is we'll take 2 times 2 times ax plus b, will substitute it as t. Okay. Now see, 2 into ax plus b, if you write it as t, differentiating on both sides, 2 is 2 only. Derivative of ax plus b will be a into derivative of x is dx by dt. Derivative of b is 0 is equal to derivative of t is 1, which implies dx is equal to dt divided by 2a. Right? We can write dx is equal to dt by 2a. So wherever dx is there, we'll replace with this. Wherever 2 of ax plus b is there, we'll replace it with t. So hence, in equation number 1, we get half of sine of, in the place of 2 times ax plus b, we can write it as t. In the place of dx, we can write it as dt divided by 2a. So 1 by 2a will come out, and multiply with 2, it will become 1 by 4a into integral of sine t into dt. Right. Now this is going to give us 1 divided by 4a. Integral of sine t is going to be minus cos t. So it will be minus cos t plus c. So this will be 1 by 4a into negative of cos of t can be replaced with 2 of ax plus b. So 2 times ax plus b, and you have a plus c. So this will be the final answer, right? So it is minus cos 2 of ax plus b divided by 4a plus c, right? So this is what we get when we do the multiplication and division of the original function with 2 and then proceed. Okay. So this is method 1. So when we solved the problem using method 1, we got the final answer as minus cos of 2 times ax plus b, the whole divided by 4a plus c. Now let's approach with another method. So method number 2 is, remember the question is integral of sine of ax plus b into cos of ax plus b times dx. So when you have a combination of sine and cos, right, either of them can be substituted as t. So in that context, if suppose I take sine of ax plus b is equal to t and then proceed. So what will I get? Observe. Derivative of sine is cos. You have ax plus b into derivative of ax plus b will be a into dx by dt plus derivative of b is 0. This is equal to derivative of t is 1. So what I can do is cos of ax plus b, I'll combine it with dx because I have this combination here, right? Then I can say cos of ax plus b times dx is equal to dt the whole divided by A, right? Now observe. So when I take these values and substitute it here, that will be integral of sine of ax plus b can be written as t. Cos of ax plus b times dx will be dt divided by a. This will give us 1 by a into, right, 1 by a into integral of t dt is t square divided by 2 plus c. Okay. So this will be 1 by 2a into what is the integral of t? Sorry, what is t? It is sine. So sine square of ax plus b is what is going to come plus c. So this will be the final answer when we use method 2, right? So this is where I wanted to discuss a very important point. If you see, the answer we got using method 1 and the answer we got using method 2 are not the same. Right? They are not mathematically, at least they are not the same, right? So this is one important point you need to make a note of. Whenever you're solving a problem based on indefinite integrals involving trigonometry, there is a possibility that you will get more than one answer, right? That depends on the approach that we follow, right? This problem will not come in definite integrals. You can see it at that point, but please make a note. Whenever you're solving a problem based on indefinite integral involving trigonometry, there is a possibility that the answer will be, you'll have more than one answer. So the question is, out of these two, which one is correct? So according to me, both are correct. Okay, let me prove that and show. So this is only for your understanding. You need to know this to become independent. Okay, please listen to this carefully. So this is the answer we got using method 1, right? So I'm taking the method 2. So let me treat this ax plus b as theta for time being. So ax plus b, if I call it as theta, then this whole thing is 1 by 2a times sine square theta plus c. Correct. We know that sine square theta can be written as 1 minus cos 2 theta, right? The whole divided by 2. Sine square theta can be written as 1 minus cos 2 theta by 2. So when I expand this, I will get 1 by 4a, 1 by 4a, 1 by 4a into 1 minus 1 by 4a into cos 2 theta plus c. Now what I'm going to do is, I'll combine this 1 by 4a plus c. It is going to give me some other constant because 1 by 4a is a constant. This is also a constant. So the final answer will be left out with is minus 1 by 4a into cos of 2 theta. So we know that theta is ax plus b. So 2 times the place of theta, I'm replacing it with ax plus b. 1 by 4a plus c, I'm calling it as some other constant k. So if you observe, this and this are the same. Because when you get the final answer, you need not worry about the constant. The constant is added as a process of indefinite integration. But the main thing we need to focus on is the final function that we have got. This function and this function are the same. And this function here is derived from the second method. So that is why I told you both the methods are correct and there is a possibility that you will get more than one answer. So you should be in a position to judge and find out whether it is right or wrong. Okay. So make a note of this.